Hello everyone, this is Darchitalia. Welcome to my channel Darshonium. In today's video, we will learn about valency. So let us first define valency. The number of electrons donated, shared or accepted by an isolated element in order to complete its octet or duplet is called as valency. Another way of defining valency is the number of electrons that an atom needs to gain, lose, or share in order to achieve a noble gas electronic configuration is called as valency. There is also the third definition of valency, which is mostly used by students because it is very small and easy. So the definition is the combining capacity of an atom is called as valency. So these are the three definitions of valency. So from the first definition, as we saw, that it needs to complete its octet or duplet. Now let us understand what is duplet. The outermost shell with two electrons is known as duplet. A complete duplet is only possible for the first shell, which is the K shell. As we all know, the first shell can hold a maximum of two electrons and hence it is called as duplet. And for rest of the shells, which is L, M, N and so on and so forth, if it is the last orbit or the outermost orbit, it should have 8 electrons. If it has 8 electrons, it is said to have its octet complete. So for K shell, it must have 2 electrons, and for LMN, it should have 8 electrons in its outermost orbit. That is, for K it is duplet, and for the rest it is octet state complete. Now for some elements, the octet or duplets are not complete according to their electronic configuration, and for some elements they already have their octet or duplet state complete. So if they don't have their octet or duplet state complete, they would share, donate, or accept electrons, as we have seen in both the definitions above. So now let us understand this by considering the first 10 elements from our periodic table. So I would make this table in which I have written the first column consists of the atomic numbers of the first 10 elements, which are numbered from 1 to 10 as shown. Now all the 10 element name I have already given you the shortcut how to memorize it, but all the 10 elements are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So the shortcut for this was hi, hello, listen, BBC news on Friday night. Now as we can see in the third column, I would write the electronic configurations. How to write the electronic configurations, I have already made a video on this. So if you don't know how to write the electronic configurations, please go and watch that video first. The link of that video, I would mention it in the description below. Learn first how to write the electronic configuration, and then you can continue with this video of how to find out the valency of the elements. So let us start with hydrogen. Hydrogen, the atomic number is 1, so the configuration is 1. So in order to get stable, it would either lose its electron in the outermost orbit or it may gain one electron. So it is either losing one or gaining one, but the number of electrons that it loses or gains is remaining 1. So the valency is again 1. Let us take the example of second element, which is helium. Helium, the atomic number is 2, the configuration is in bracket 2. We know that the first orbit can hold a maximum of 2 electrons and helium is having that 2 electrons present. So will it accept any electrons? Answer is no. Will it donate some of its electrons? Answer is no, as it has its duplet complete. So it is neither accepting an electron nor it is gaining an electron. So there is no loss or gain of electron, and hence the valency becomes what? 0 because no electrons are involved. Now let us consider the example of lithium. The electronic configuration is 2 comma 1. Here there are two ways in which it can gain stable configuration. Either the lithium can lose one electron and gain 2 electrons in the first orbit, or it may gain 7 electrons from some other element and it may complete its octet in the second orbit. But what is easy? It is always easy to lose one electron rather than borrowing 7 electrons. Correct? Concept समझ में आया? So it would donate one electron. The number of electrons donated are 1. So valency becomes 1. Simple है. Similarly, let us consider the example of beryllium. Beryllium at 2 comma 2. So it has 2 electrons in the outermost orbit. As beryllium has 2 electrons in the outermost orbit, it can do two things. It may lose 2 electrons again to complete its duplet, और इट मे गेन 6 इलेक्ट्रॉन्स इन ऑर्डर टू कंप्लीट इट्स ऑक्टेट. अब वो क्या प्रेफर करेगा? ईजी क्या है? टू लूज 2 इलेक्ट्रॉन्स. एज इट लूजेस 2 इलेक्ट्रॉन्स, द वैलेंसी ऑफ बेरिलियम इज 2. Similarly, the boron, the electronic configuration is 2 comma 3. So the boron would again prefer to donate its 3 electrons in the outermost orbit. As it is donating 3 electrons, number of electrons that are donated are 3. So valency becomes 3. Very easy. Please remember, in case of carbon, the electronic configuration as we can see is 2 comma 4. The carbon would always prefer to, please keep in mind, to share electrons. So the carbon, in order to complete its octet, would share their 4 electrons. So as it is sharing how many electrons? 4 electrons. The electronic configuration it acquires is of neon, which is 2 comma 8, by sharing of 4 electrons. So number of electrons shared are 4, so valency becomes kya? 4. Next element is nitrogen. Nitrogen, here we can see the electronic configuration is 2 comma 5. Up, tell me, either it may lose 5 electrons or it can gain 3 electrons and complete its octet. What would it prefer? Up, it would gain 3 electrons. So nitrogen is gaining how many electrons? 3 electrons. Uski valency kya ho gayi? 3. Easy. So let us consider the example of oxygen. Now oxygen, the configuration is 2 comma 6. Now it again has two options. It may lose its 6 electrons and complete its duplet, or it may gain 2 electrons and complete its octet. Which one would it prefer? Obviously to gain 2 electrons. If it is gaining 2 electrons, the number of electrons gained are 2. So valency kya ho gayi? 2. Easy. Now it would be very easy for you to find out the valency of fluorine. Fluorine is 2 comma 7. It would obviously prefer to gain 1 electron and complete its octet in the second orbit, right? So it is gaining 1 electron. So valency kya ho gayi? 1. Now last example is of neon. The electronic configuration is 2 comma 8. Its second orbit, that is the outermost orbit, contains 8 electrons. If it is having 8 electrons, that is its octet is complete. So if its octet is complete, will it gain, share or donate any electrons? Answer is no. So it is not donating any, gaining or sharing any electrons, and hence the valency becomes 0. Easier. Now again, I would give you for practice the next 10 elements, which is from sodium to calcium. I've written all the atomic numbers starting from 11 to 20 and all the names of the elements also shown. I've already done a video over the shortcut how to memorize these 10 elements. If you don't know, then it is Na Mango Allah Se, Pepsi Soda Cola or Kaju Cake. So ये वाला shortcut please memorize. So these are the next 10 elements. I hope you can write the electronic configuration on your own and also find out their valencies. So pause the video right now. Then at the end of the video, I will display all the answers of the next 10 elements, that is from sodium to calcium. I hope that all your answers are correct and you have learned how to find out the valency of an element. So this was my video on how to find out the valency of an element. If you liked this video, please smash out the like button. If you have any suggestions or any queries, please comment right below. Please share this video with all your friends. Thank you for giving me all your time. I hope you enjoyed. सब लोग मज़े करो. Thank you.